It's the last video in hematology, at least for now, because I still have bonus videos, and let's talk about coagulation disorders later. Next Saturday, by the way, we're going to start a new series, which is about fluids and electrolytes, acid-base disturbance. So today, let's talk about ESR, a garbage test. Just get your blood in a test tube and wait for like an hour. The red blood cells are going to sediment. You get your ruler that you used to use in 5th grade and measure this distance, and boom, you have your ESR. Useless. Words of wisdom. ESR is one of the most worthless tests there is, and yet one of the most commonly ordered. And it means absolutely nothing. I love it. Is this how we're gonna start a video about ESR? Yes, indeed, because it's garbage. Mostly. As you know, your blood is made of plasma and cells. Cells mostly are red blood cells. We're talking millions. That's why the normal hematocrit is 45%. Let's talk about plasma. 55% of blood, water and proteins. Mostly water. By the way, how much water? 5% of your total body weight. So if you're an average adult male and your weight is 60 kilograms times 5% equals 3 liters of plasma. 55%. 45% cells, about 2 liters. That's why your normal blood volume is about 5 liters on average. Water has electrolytes, and proteins are albumin and globulin. Albumin, small but numerous, and it's responsible for the oncotic pressure, because in osmosis we care about the number of particles, not the mass or the size. We care about numbers. Albumin is most numerous. It exerts the most osmosis. Globulin is large but less numerous, and we have types of globulin. We have alpha globulin, beta globulin, gamma globulin, which are your immunoglobulins, and the beta globulins are your clotting factors. What happens when you leave blood in a test tube? It sediments. It's called gravity. Okay, this is the oxygenated blood because we get it from the vein, and this tube is called Westerern tube. And we add an anticoagulant because what's the use? And when you leave it, it's gonna do it like this. 55% of plasma on the top. It's light. It's watery. Then the red blood cells are gonna sediment. They are heavy, increased density. So they are in the bottom. Between the plasma and the red blood cells is the buffy coat layer, very, very, very thin, and contains white blood cells and platelets. Your red blood cells are in millions. These are thousands. They are teeny, teeny, tiny if compared to the red blood cells. Look at this wonderful definition. Erythrocyte sedimentation rate, the rate at which erythrocytes sediment. Genius. As you know in physics, any rate is change in something over change in time. The denominator has to be time. So we know velocity, change in distance over change in time, ESR, change in distance over change in time. Reported in millimeters per hour. So leave this test tube for 1 hour, and let's say that your normal ESR was 15 millimeters per hour, which means after 1 hour, we measured this distance or length, and it was 15 millimeters. Today, it's performed via automated analyzer. Do you think like the pathologist has time to measure this distance with his ruler? No, he's in his Ferrari. The lab technician is doing all the work. As time passes, sedimentation increases, but ESR stays the same because it's a rate, you idiot. So, here is at 0 time. 15 minutes, it's gonna be like this. 30 minutes, it's gonna be like this. 1 hour, it's gonna be like this. ESR stays the same, yes indeed. You want proof? Okay, let's measure this. So let's say that this distance is 10 millimeters, and in half an hour, which equals 20 over 1, which equals 20. So the ESR is 20 millimeters per hour. After 1 hour, this distance was 20 over 1 hour, so the normal ESR is 20 millimeters per hour. See, it's the same. Sedimentation increases, but ESR stays the same. It's a rate. And here's a quick joke for you. What do they call a test tube that has finished its higher education? Answer, a graduated cylinder. Ha ha ha. Steps of sedimentation. First, rouleau formation. Red blood cells are stacked on top of each other. Then settling, then packing to the bottom of the test tube. It's like the average American adult. First, they live together. Then they settle down and marry. Then, after they become empty nesters, they pack their stuff and move to a smaller house called downsizing. What are the normal ESR values? If you are a man under 50 years old, the normal is 15 or less. If you're a woman less than 50 years old, it's 20 or less. Men more than 50, it's 20 or less. So the ESR increases as you get older, generally speaking. Women over 50, 30 or less. Factors affecting sedimentation. We have pro-sedimentation factors that are increasing the sedimentation and increasing the ESR, or anti-sedimentation factors decreasing sedimentation and decreasing ESR. The pro factors are fibrinogen and immunoglobulins. Basically, they are plasma proteins. Anything that increases role of formation, which was the first stage in sedimentation, will raise the